Great. So today we're going to start talking about laws of sines. And the laws of sines are really important so that we can solve every side and every angle of any triangle out there, okay? The first video, the review video, for those of you that did not watch it, is just going through this stuff really quickly. Or I'm sorry, at a much slower pace. I'm just going to go through it really quickly with you. Basically, there's an area formula for triangles to find the area of any triangle. Keep in mind that you can find the area of any triangle as long as you know the height, right? But if you don't know the height, if you remember from geometry, you can use one of these three formulas. And it basically is for any time you're given a side, another side, and then the angle that is in between it, okay? And so we can kind of go through, we can find the area of any triangle that we want to if we use one of these formulas. Again, it's doing the two sides and the angle in between, okay? The other thing that was talked about at a much slower pace was just being able to use the laws of sines. And so the laws of sines is this formula right here. You definitely need to know this, okay? But you do the sine of an angle divided by the length of the side across from it. That ratio is going to equal the sine of another angle and the ratio that is across it. That's also going to equal the sine of the other angle and the ratio that is across it, okay? So if we go through and we do a couple of examples, the first thing that I need to double check, or I need to reinforce, I should say, is that if you're given a side angle side, so if you're given side C, side B, and then the angle in between, you don't have the side length across from it. So you're not able to use the laws of cosines. So we end up doing the laws, you can't use the laws of sines. You end up using the laws of cosines for an SAS, and that's tomorrow's lesson, okay? But here's a couple of examples. So if I went through and I said, okay, I'm given an angle, and then a side. So I'm given two angles and then a side of a triangle. Can I use the laws of sines and figure out every other missing piece? So the missing angle and the two other missing sides of the triangle, okay? Very quickly, keep in mind there's 180 degrees inside of a triangle, so you can always just subtract and get the 91 degrees for the other one. And then you just set up a proportion, cross multiply and divide. Set up a proportion, do some cross multiplying and dividing. I do want to reiterate to you very quickly as well that it is important that you start using degree symbols. And so if you have a 91 degree angle, 180 degrees, 40 degrees, 49 degrees, that the sides are not degrees. And so sometimes those numbers end up being similar to each other. They're in the same range. And so you definitely want to make sure that you're not forgetting degree symbols for stuff. Okay, so here's another example. What if you were given an angle, if you were given here's an angle, another angle, and the side in between it, so an angle, side, angle, right? Can you still do the laws of sines? And the answer is yes. So again, we're going to do the 180 thing. So 180 minus 141 minus 23 is going to give us 16 degrees. And then you can set up your proportions. So the sine of 16 over 9 is going to equal the sine of 23 over f. Or the sine of 16 over 9 is going to equal the sine of 141 over e. Do a little bit of cross multiplying and you can solve for those two missing sides. What gets hairy with laws of sines is when you are given two sides and an angle, and it's not included anywhere, okay? And so with this particular case, it's kind of weird. And so I just wanted to show you what it's going to look like. I want to draw a couple pictures for you and explain this one in a little bit more depth, okay? So first of all, if you're given a side, and an angle, if you write this backwards, it gets you a bad word, okay? But if I draw the picture, sometimes it's easier to draw the picture backwards. And so you have a fixed angle. Okay, this is a fixed angle. There's a fixed opening right here. Okay, you have another fixed side that's next to it. And then you have another fixed side, but what's going to happen is that this angle in here is not necessarily fixed. And so this angle up here could go and be anything, and it can move around, and depending on what the length of this side is going to depend on what that opening actually is. And so that's what we're going to spend a little bit of time talking about right now, okay? All right, so the first thing I want to talk to you about, and I just wanted to get a cleaner picture for you, a cleaner page for you, but the first thing that we're going to talk about is, okay, so you're given a side, and an angle. This is what we call the ambiguous case, okay? The first thing we're going to do is talk about when the angle is acute, okay? And so here's what you have. You basically have this angle. I'm going to draw that same picture that I did before, okay? So here's angle A, and it is an acute angle, and it is a fixed angle, this opening, right? Remember, this is a fixed angle, okay? And you have a fixed side. Now, I'm going to call this side B just for the sake of easiness to talk about, okay? And then the side, remember, that's across from angle A, that is going to be side A, okay? So here's what can happen. If side A is really super short, and that angle at the top is hinged, and it's not fixed, you can think of it as being on a hinge, this side can swing and go wherever, this side right here, because remember, this opening is not a fixed opening. But if side A is really super short, it's not going to make a triangle at all, and it's kind of weird, okay? So we're going to come back to this in a minute. What if your angle is fixed? So here's your angle A, right? Here's your angle B, but then your side A ends up being a perfect perpendicular line, okay? What does that equal? What is this side on the triangle called, right? It's actually the height, right? This is the height. And so if the angle, if the side A, right? So if the side that is opposite your fixed angle is equal to the height, then you're going to get one triangle, and it looks like this. But if that side A is shorter, so I'm going to come back over to this picture. What if side A is shorter than the height, right? And it swings and swings and swings. It's never going to reach this fixed opening down here at the bottom. So if your side that's opposite of the angle is less than the height, then you're not going to get a triangle at all. Okay, and so I know that sounds a little bit weird, but that's how this is going to kind of work, okay? So there's a couple of other things that can happen, and I definitely want to talk to you about those as well, okay? So one more time, if you're given a fixed angle, you're given a side and another side. If that side equals the height, you're going to get a triangle. You're going to get a nice, pretty little right triangle. But if that side is smaller than the height, right, it's not going to give you any kind of triangles at all, okay? But what if that side is a little bit longer? All right, so I drew you a little picture. I kind of want to get this set up and show you what this is going to look like. So again, we have this acute angle. So remember, we are talking about this angle being acute right now, okay? But I have this acute angle. It's a fixed opening, okay? I have the length of a side. Here's my height drawn in. But what if my other side A is just slightly longer than my height? Just slightly longer. So what's going to happen is side A could be over here. Or if I remember, right, this hinge, if this is on a hinge, this opening, it could swing in and be right here. Okay, and so what happens is, if your other side, the side that is opposite the angle, is between, so if that side is smaller than B, but it's a little bit longer than the height. Okay, so it's a little bit longer than the height, but not quite the length of B, then you're going to end up with 2 triangles. Okay, because this could swing, it could be out here, or it could swing in and can go right here. Okay? All right, so here's the last thing that could happen, okay? So remember, we've got this fixed angle, we've got side B. What if side A is equal to side B? If it's the same length as side B, if I swing it open, I'm going to get 1 triangle over here. And it happens that it's going to be an isosceles triangle, okay? So if A is equal to the length of B, okay, I'm going to get 1 triangle. But what if it's a little bit longer than B? So if my side A is just a little bit longer, so remember, this is when it equals B, okay? If my side, let me get a different color pen so you can see this a little bit, maybe a little better, but if my side is a little longer, okay, so this is when A is bigger than B, then I'm still only going to get 1 triangle. And so we say that if A is greater than or equal to B, you end up with 1 triangle. Keep in mind, these are not the same thing. Okay, they're not the same thing. Okay, on page 724, there is a table that works out, it shows all of this for you. Let me go find it so you can kind of see it. So here it is, this triangle, or this picture, and they're just saying basically the same thing that I just said as well, okay? And I'm actually going to show you something really cool in a little bit that you can see as well if this is a little too confusing, okay? Okay, so the last thing that I wanted to talk to you about really quickly is what do you do if A is obtuse, right? Or if it's a 90-degree angle, okay? So if your angle A is a 90-degree angle, right? Here's side B and here's side A. Or if it's obtuse, here's side B and here's side A. Notice that side A is shorter than side B, okay? So if that happens, if side A is less than side B, then you're not going to get a triangle at all, okay? This can swing and swing and swing. It's never going to reach the bottom. This could swing and swing and swing, never reach the bottom. If you look at an obtuse, or if you look at when the side A is actually bigger, okay, or greater than the length of side B. Now, if it's equal to side B, right, it's going to be straight up and down. You can't build a triangle with that either. And so if this is a right angle, you're going to get 1 triangle. If it's an obtuse angle, then you're going to get 1 triangle, okay? Okay, and so what does this look like in terms of an example, Ms. Hunsker? What does this look like in terms of this happening and when this happens, okay? So let's go through, we're going to do an example, and I'll show you what that looks like, okay? So let's say that you are given that the measure of angle A is 30 degrees, side A is 11, and side B is 17. Okay, so first of all, we have an acute angle, and if you go back and look at our acute angles chart, right, we are basically comparing that side that's opposite to the height. So the first thing we have to find is the actual height of that triangle. All right, so I went ahead and found the height using simple trig, just SOHCAHTOA stuff. And I got 8.5, and so that means that there are 2 triangles. Okay, so here are the 2 different cases that it can be, and I went ahead and drew the picture for you and set it up. So because the H is between, because 11 is between the height and 17, it can look like this or it can look like this. Now when you go to set it up, you're going to end up with angle B to be 50.6 degrees, so close to 51. But on this triangle, angle B is actually obtuse, and so you have to use a reference angle. And so angle B is actually going to equal 129.4. Now, I went ahead and set up all of the different proportions and found them, but I'm going to go over this a little bit slower in the next video for you.